This is Britt Caswell with another example video. In today's video, I'm covering example 3 from lesson 7-6 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to analyze a sine or cosine function. Y'all, this is probably going to be a long video, okay? So I'm going to walk us through on the first part of it. We're going to graph it together and then identify those key features. And then when we get to the the try it part of it, we're just going to look at the equation to identify those key features, okay? Just to kind of compare and contrast them. I think it's easier to see with the graph, and I think we need more graphing practice, so we're going to go ahead and do that, all right? So here we go. So on this first equation, all right, I'm going to start with our general graph, which has these anchor points. Now look at what's happening. So we have a 4. So what that's going to do is it's going to go from having an amplitude between 1 and -1 to dealing with 4 and -4. All right. In fact, I can go ahead and I can pop them bad boys on here, right? Remember, it almost looks like a V when you don't have the line in there. That's how to remember it's a cosine. Okay, so instead of being at 1 and -1, which would make it look like this shape, I'm popping it up to 4 and -4. That's what that 4 does. Okay. Now the 3 here in front of the x, that is going to be a horizontal compression. It's horizontal because it's in the grouping symbol. It means this pattern is going to happen 3 times before pi over 2. So what I'm going to do is I'm going to cut each of these sections into thirds. And then I'm going to divide their distance from the y-axis by 3. Okay, so this one is 1, 2, 3 tick marks away. Now it's only going to be 1 tick mark away. This one is 3, 6 tick marks away. 6 divided by 2 is, 6 divided by 3 is 2. So this one's now going to go here. This one is 3, 6, 9 tick marks away. 9 divided by 3 is 3. And this one is 3, 6, 9, 12 tick marks away. 12 divided by 3 is 4. So it is now 4 tick marks away. So those are my anchor points on this. And then there's a +1 that shifts everything up by 1. So we're just popping them up 1 on the axis. All right. So now that we've gone through and we've graphed it, okay, mind you, I could copy my little check marks and keep making my curve on there. Because really we want it between 0 and 2 pi. I'm okay with just this though. I'm good with what I've got. So now let's identify the key features they want. So our amplitude is the distance from these middle points to the top. All right. So our middle points are at 1 and our top is 5. So that's a distance of 4. You get that from taking the absolute value of this number, right? It's always positive, whatever that number is. Now our period we get that by doing 2 pi divided by b. So we did 2 pi divided by 3. Which kind of makes sense, right? We took all of this and divided it by 3. So this is 1/3 of 2 pi, if that makes sense. All right, or you could think of it as 2/3 of pi. Anyway, so our phase shift, we didn't shift anything to the left or to the right, right? So we had no phase shift. You could see that in the equation because there's nothing being added or subtracted from the x. However, our vertical shift, we definitely saw it went up by 1. All right, that's where we took each of these and scooted them up there at the very end. and it comes from that plus 1 right here. Now our maximum and our minimum, they're affected by your amplitude and your vertical shift. All right, so our new maximum, instead of being 1, it was stretched to 4 and then scooted up again till 5. So our maximum's at 5, and our minimum was originally stretched down to 4 and then scooted up to -3. Most of these you can get from the equation pretty easily, but the minimum and the maximum, I find that most students can't do unless they do a rough sketch. Okay, let's try this again. So this one's talking about a sine function. So I'm going to start at kind of our generic graph. Pi over 2, Miss C, what are you doing? Okay, so remember the sine starts at 0, goes to 1, goes to 0, goes to -1, goes to 0. I have it so close because I know that we're going to be doing some wacky stuff with it. Alright, so the 3 that's on here says that instead of going to 1, it's going to go to 3. Instead of -1, it'll be -3, so just those 2 points move. Now the negative that's on that 3, remember, flips our graph upside down. So instead of this going to +3, good grief, it's going down to -3. And instead of this being at -3, it's going to pop up to +3. Okay, so that's what that -3 did. It flipped your graph upside down and it stretched it. All right, now we have this plus pi over 2. That is going to tell us to shift everything to the left by pi over 2. Gosh, dang it. Remember, it always feels, ooh, that's hideous. Remember, it always feels backwards, right? So when it says plus pi over 2, it goes left, and when it says minus pi over 2, it goes to the right. So this plus pi over 2 says come to the left. Now, notice my tick marks. One tick mark is pi over 2. So I'm moving each of these to the left by 1 tick mark. Okay. And then this -2 is saying to shift everything down by 2. So there's down 2, down 2, down 2, down 2, down 2. And I recommend labeling these points so that you know what the heck they're at. Okay. So this is at -5 clearly. So 0, -5. These ones were at 0 and then shifted down 2. So this is like pi over 2, -2. So that's negative pi over 2. This one's positive pi over 2, -2. And this one's 3 pi over 2, -2. And then this one, remember, it was up 3 and then it went down 2. So this one's at 1. All right, and we can draw our little curve in there for the sine. It makes us feel better. Okay, so now let's name it out. So our amplitude, remember, is our distance from our midline to our maximum. So it's going from -2 to 1, which is 3. You can also get that from the equation by taking the absolute value of this number. Remember that amplitude has to be positive. It cannot be negative. Now our period is 2 pi divided by b, which is the number in front of x. There's no number in front of x, so our period here is 2 pi. Our phase shift is describing our left and right translations. So we went to the left by pi over 2. Now, if they're asking for just a single number on there, call it negative pi over 2 for your phase shift, because the formula, our handy dandy formula, which I should cut and paste and put on this slide. Do you see how that formula has a minus in front of that c? That's why it would be a minus pi over 2, because it needs to be minus here. Our vertical shift, which way did we go? We went down 2. Now our maximum is our new highest value, which is here at 1, and our minimum's down here at -5. So see why it's so much easier to graph it real quick to see those max and min? I'm going to try it with the try it to see if I can do it just from looking at the equation, but I really struggle on that. So I'm also going to make sure I have the try it up on my screen so that I can answer it and make sure that I'm not lying to your young impressionable minds. Alrighty, let's look at this now. So starting with our amplitude, this one's pretty easy. It's 1/2 because it's the number in front of the sine. Our period is 2 pi divided by the number in front of x. So since x just has a 1 in front of it, our period is 2 pi. Our phase shift is our horizontal translation. So this is going to the right because it says minus, and then pi over 3 units. And our vertical shift is addition or subtraction outside of our grouping symbol. So this is shifting down by 4. Here's where things suck. So I'm going to do I'm going to do a quick sketch. But I'm not going to go that crazy. Okay, so let's see. So here's some tick marks to help us along. So originally it goes from 1 to -1. But now it's going from 1 to 1/2. I shouldn't have put my tick mark so small. Judgment. And then it'll go down 4. So our maximum was at 1/2, and then it went down 4, which would put it at negative 3 and 1/2, right? So our maximum is negative 3.5. And then our minimum, right? So if our amplitude is 1/2, so to get to our midline, it would be at -4. And then to get to our new minimum would put us at -4.5, so negative 4.5. So I didn't draw the rest of the graph, I just drew my y-axis so I would know where the heck it went. I think that might be what you do too. Might make your life a little easier. Okay, so let's identify our transformations here. So our amplitude, change color, get it a little exciting. So our amplitude is just a 2 because that's the number in front of the cosine. Our period, see how there's a 2 in front of x? So it's going to be 2 pi divided by 2, which is pi. Okay, so this is a horizontal compression. Our phase shift, we can't identify our phase shift when it's written like that because we need it to be written like this, where it has the b outside the parentheses. So I'm going to need to rewrite my formula real quick where I factor out that 2. Oops. So I'm going to have 2 times the cosine of 2 times x, and then pi over 4 divided by 2 is pi over 8, and then plus 2. God, there's a lot of 2's here. Calm down, Savvas. Alright, so now I can identify that phase shift is actually pi over 8, not the pi over 4 that's there. See, they tried to trick you. And so that plus is telling you it's left by pi over 8. Alright, now the vertical shift, that's the 2 that's being added here, so it goes up by 2. Then we get to the dang maximum and minimum. Okay, here we go. So originally we start at 1 and -1, but that 2 there puts us at 2 and -2. And then we have this vertical shift that scoots it up another 2. So our new maximum's at 4, and our new minimum is at 0. So there we have it, guys. That is how to analyze a sine or a cosine function, both by just analyzing the equation, but also looking at the graph. Until next time.